Sorry. Who among you are at pace right now? Anyone? Raise your hand. Or all of you at home? Oh, wow. The Ed Media, I think you're using the one that we have in our room, right? For those at Ed Media. So how many of you are there in Ed Media? Or how many are you in the classroom there? Oh, wow. Well, I have to take into consideration some of your classmates who may be in New Jersey who's affected by this, what we call northeaster. So I have to do the thing. Even right now. So I think some of your class was also remote today. So sorry for this thing, but the advantage that we have for today is we can record the lecture. And what I did is just going to ask some questions that is related to the course that we have. So if you're going to remember, we are already in chapter 7 and we're almost done in the chapter 7. Okay, so we have what we call discuss already about this so-called quantum numbers. So the discussion that we have in the quantum numbers, okay, so you can lower now your hand to those who still raising their hand. So as I have mentioned to you last time, so we have what? 4 quantum numbers. And if we're going to look at these quantum numbers, we say it's the N, the L, the M sub L, and the M sub S. So if we're going to what we call look, okay, at these different quantum numbers, I have told you that the first 3 quantum numbers usually tells you the location or the orbital where the electron is located. So N refers to the size. And usually, as we have mentioned, okay, I think the principal quantum number. So N refers to the size. The smaller the value of N, the lower the energy and the smaller the orbital. So the principal quantum number or N, okay, they can have a positive value 1, 2, 3, and so on. Okay, so if we're talking about N, we're talking about shell. So orbitals with the same value for N are said to be in the same shell. Now the N value that you have are all positive numbers. Now the second quantum number, which is the angular momentum quantum number, it refers to the shapes. And its value depends on N. So the value of L is usually from 0 to N minus 1. So if your N is equals to 1, the value of L is only equals to what? 0. Okay? And with N is equals to 2, you can have a value of L that is equals to 0 and a value that, of L that is equals to 1. Now L, if N is the shell, L is your so-called subshells. So when N is equals to 2, you have a subshells there of L equals to 1 and L is equals to 0. So we could say this is what? 2, 1 and this is 2, 0. But to avoid the confusion, they assign some letters, small letters to L values. So instead of making 2L, you say it's 2P. Not 2L, 2, 1, you put it as 2P. And in case of L equals to 0, you assign it as 2S. So that's why when the quantum number is 1 and 0, that refers to a subshell known as 1S. Okay, so orbitals with the same values for N and L are said to be in the same shell and subshell. So this is one subshell, and this is another subshell. Okay. Now, if we're going to look at the letters that we have here, so you have S for L equals to 0, P for L is equals to 1, D for L equals to 2, and then for F, okay, we refer it to L equals to what we call 3, and each of them is what we call a subshell type. Now, later on, you will know why do you call this SPDF. The way that you remember, the S is for spear, P is for peanut, D is for double peanut, and F is for flower. And you will know later on why I mentioned those words. Okay, so that refers to the shape. Now, the third one, the third quantum number, that is in terms of spatial orientation. So this quantum number distinguishes the orbital of a given N and L. So what does it mean? So if you have a 1s or a 2s and a 2p, how does the subshells differ from one another? Okay, so you have the energy, that's the first quantum number. You have the shape, that's the second, or what we call quantum number. But what does the third quantum number tells us? It tells us about the spatial orientation. And the value that it has depends on the L. So usually the value of M sub L is just equals to, okay, L from the negative L to positive L, including 0. Now, usually, if you're going to count the L values that you have in a given M sub L, you end up with getting the numbers of orbitals. Okay, so each different value represents a different orbital. So for a given subshells, there will be 2L plus L values, and therefore, the 2L plus L plus 1 is the number of the orbitals. So when L is equals to 0, how many orbitals do you have? Anyone? You have 1. So when L is equals to 1, how many orbitals do you have? You can put your answer in the chat. So if you're going to look at this, how do we get the number of the orbitals? So when 2 times 0 plus 1, you get 1. So that's what you have. So when 2 times 1 plus 1, how many orbitals do you get? You get 3. And you can determine what are those orbitals. So if L is equals to 1, so possible values of M sub L would be -1, 0, and +1. So each of them represent an orbital. Okay. Later on, we have a lot of reviews because we're almost done here, but I want you to prepare for the second exam. Now, if we're going to summarize the one that we have so far, when N is equals to 1, the L has only one value, which is equals to 0. And when L is equals to 0, your M sub L also has only one value. So the first shell that you have there is one subshell, an S subshell, and that subshell has one orbital. So the way that you're going to look at this N, L, M sub L, shell, subshell, and in each subshell you have the orbital. And in the orbital, that's where you find your electron. That's why to determine the address of your electron, all you need to know is the first 3 quantum number. So when N is equals to 2, your L has 2 value, which is 0 and 1. Now, when L is equals to 0, the M sub L only has one value, and that's 0. So there is only what? A 2s subshell with one orbital. But when L is equals to 1, your M sub L has only 3 values, -1, 0, and +1. So your 2p subshell has 3 orbitals. And then so on. when n is equals to 3, L has three values, 0, 1, and 2. I think there's a summary that we have here like this one, telling you this is the n, this is your L, and this is what we call your M sub L. So the question that can be given to you is, how many orbitals are there when L is equals to, let's say, 2? How many orbitals are there when n is equals to 2? So how are we going to answer that? So let's start with this question here. So how many orbitals are there when L is equals to 2? So all you need to do, you look at the L and look at the one that is a value of what we call 2. And you count how many orbitals you have there. 1, 2, 3, 4, 5. So when L is equals to 2, you have 5 orbitals. So those are the type of questions that you'll be asked. Now, when n is equals to 2, what are you going to do? How many orbitals are there when n is equals to 2? So you get to go here and this one. And then you count all the orbitals that you have there. So how many orbitals are there when n is equals to 2? Anyone? This is when n is equals to 2. Okay, so if you're going to do is 1 plus 3, so that is equals to 4. But is there a shortcut to determine the number of orbitals when n is given? Can we say n for the number of orbitals for n, that's just equals to what? N squared? No, you don't have the table. You will not have this table on your exam. To get the number of orbitals, what's the table? Or what's the equation? We use m. If you're going to look at this one, you're going to use this one to get the number of orbitals when L is given. So you have 2L plus 1. That is to get the number of orbitals given the L. But how do you get the number of orbitals if the one that is given or being asked is n? All you need to do is n squared. Let's use the formula. So when n is equals to 1, how many orbitals do we have? Hello? So when n is equals to 1, there's only 1. And if we count it, this is just the orbitals that you have there. Now when n is equals to 4, how many orbitals do you have? So n or 4 squared is equals to 16. So let's look if 16 is the right one. So we go here in the portion where n is equals to 4. So all you need to do is what? Count all the orbitals when n is equals to 4. So you have here 1, you have here 3, you have here 5, and you have here 7. And when you add them together, that is equals to 16. Okay? So let's see later on, because as we end this thing, I'll just ask you some multiple choice question. So that's the thing that I need to fix because I cannot log in my Pay Zoom. So I log in through the classes. So if we're going to look at the subshells, just to give you an idea, so the 1s is given here, the 2s is here, and the 2p, and then the 3s, and the 3p. So if you're going to look at this, the s is only 1 orbital, the p has 3 orbitals, the d has 5, and the 4 has what we call 7. Okay? And you're going to look at it, their energy level is arranged in such a way, the higher the value of n, the higher is the energy level. Okay, now if we're going to compare what is this quantum numbers all about, if we have the n, we could say we can refer it to the size of the house. The bigger the n, the bigger is the size of the house. For the second one, the shape of the house, so it has something to do with, depending on the quantum number L, you're going to have different shapes. So let's say an L equals to 0 would have a shape of the house like this one. An L equals to 1 has a shape of a house like this. An L equals to 2 has this what we call house shape. So the same thing in the orbital. Later on, I'm going to show you what's the shape of these subshells that you have. And if you have the M sub L, it refers to the orientation of your home. Okay, south, east, west, and we could say north. Now, the last that we have here in terms of the quantum number, this is the spin quantum number. And there's only two possible value for this. Either you have what? +1/2 or -1/2. So this refers to clockwise and counterclockwise. And since you have two values here, so what does it mean? An orbital can accommodate at most 2 electrons. So that's what it means in terms of the spin quantum number. So if you're going to put a quantum number series, or what we call N, L, and F sub L, so you could see there will be two quantum numbers wherein one is 1/2 and the other one is 1/2. So this one refers to 1 electrons and this one refers to another electrons. So that means in each of the orbitals, you can accommodate at most 2 electrons. Okay, so this is just the M sub S value. So let's look at the question here. Which of the following are permissible sets of quantum numbers? So what does it mean? Is this quantum number referring to an orbital? So you have to look at the rules. Let's go on the first one. Is this permissible? Is this allowed? So you may ask yourself, Professor, how do we know if it's allowed or not? So you have to look at the value. So you just have to look at the set of N, L, and M sub L. So as you could see, the L depends on N, and the M sub L depends on the L values, and the MS is just equals to either 1/2 or -1/2. So if we're going to look at the first one, what makes it wrong? Which quantum number makes it wrong, or which quantum number does not make it allowed? Okay, it's this one. Why? When N is equals to 4, what's the possible value of your L? It's from 0, 1, 2, and 3, right? Because your L is equals to 0, 2, and -1. Are we clear on that? Now your M sub L, if ever it was equal 0, it is allowed even if your L is 0, 1, 2, or 3. So this is the one that messed up that thing. Now the second one, is it allowed? Is the second set of quantum number allowed? Okay, the second set is what we call permitted. That's allowed. So 3, so possible value of L is from 0 to 2. So if you have L is equals to 2, possible value of M sub L is from -2 to +2. How about the third one? Is it allowed? Is the third set of quantum number allowed? The answer is no. What messed it up? Which quantum number messed it up? This one. because m sub s could only have a value of either +1 or -1. How about the last one? Is it allowed? Is the last set of quantum number allowed? Okay, the answer is you have a 5. So when L is when n is equals to 5, L would be from 0 to 4. And since this is L equals to 3, so the value of m sub L is from -3 to +3. So we could say that is allowed. Okay, m sub L can get a -3 because the value of m sub L is equals to what? The positive L, the negative L to positive L, including 0. Is that clear? So the way that you do it is the second or the next quantum number depends on the previous quantum number. Yeah, you're going to have a lot of what we call question. So I'm talking about the atomic orbital shape. So I told you the S, the P, and the D. Okay. Usually, yes, it's given the N because that's where it is. If ever you're not given the N, then you're just referring to the subshells. Okay. So the S is what we call spherical. The P is P orbital just 2 lobes along a straight line through the nucleus with 1 lobe on either side. Now a D orbital has a more complicated shape. So this is what we call the S orbital. It's just spherical. And if you're going to look at this, you have here what? This is the 1s orbital, and then you have a 2s orbital. So you could say in terms of size, the 2s is bigger than 1s. Okay, if you cut it through a thing like a Pac-Man, so this is what you have. Now the p orbitals, as I said, is the peanut shape, right? I don't know if you're going to agree with me. It's like a peanut shape here. So you have how many orbitals in a P? When L is equals to 1, how many orbitals do you have? So this could be your -1, this could be your 0, and this could be your +1. You have 3 orbitals. Okay. So how does it look like? It can be a 2px orbital, a 2py orbital, or a 2pc orbital. So it's just like a peanut. And then the other one, the description that I have for the D, I would say a double peanut. Because you have here like this, and then you have like that one, except for this thing. So a D is when L is equals to what? 2. And when L is equals to 2, you have 5 orbitals. And what are these orbitals? This one, this, and this. You don't need to memorize. All you need to know is, you know, at least there's 5 orbitals here. Now for the F, just in case that you have here, I said that's the flower shape. So this is how it looks like. So this is the summary of the S, P, D, F orbitals. Now, if you're going to look at this, okay, you have a 1s, and then you have a 2s and a 2p, and then you have a 3s, a 3p, and a 3d, and then you have a 4s, a 4p, a 4d, and a 4f. I hate that. I'm living in 3rd Avenue. That's why I live here in this avenue. So as you could see, there's no d orbitals in 1 and 2. There's no f orbitals in 1, 2, and 3. So that's another thing that you need to know. Okay, so the next series that we have is just your participation. You're going to select which is the right answer. So before we started on that, do you have any question? Before we go on this polling thing. So this one. So I want everyone to participate in the poll. I just keep repeating this thing. So the number of orbitals having a given value of L is equals to what? So how many of you? You should be 50. So let's see.
See?
So where's the 15? There's only 35 or 37. Okay. So let's see. Oh, it's really? I don't know how. Now I lost the poll. You see it now? So maybe the way I'm going to do is I'm going to post the question and then get the poll, okay? Because in my device, I put it on the clear area, okay? So you cannot at least, some of you in the cell phone, you will not be able to see it. So I'm going to end the poll. And this is what you have. So at least 45% get it correct. 20 out of 44. Okay, the number of orbitals is given by the equation ML or 2L plus 1. So when L is equals to 2, how many orbitals do you have? So 2 times 2 plus 1, you have 5. So that's the answer that you have there. So let's try the next one. So I'm just going to pose the question and then I'm going to what we call put the poll. So the angular momentum quantum number is best associated with the energy of the orbit, the energy of the orbital, the number of orbitals in a subshell, the orientation in space of an orbital, and the shape of the orbital. So I'm going to post now the poll here. So let's see. As of now, you should know the 4 quantum number and what they refer to. So I only have 36 participants. Okay, so let's end it. So if we're going to look at the results, at least majority of you got it right, but I'm still not impressed because only 56% of you got it correctly. And if we're going to discuss this one, so there's no orbit there. So the energy of orbital, what quantum number is that? That's the principal quantum number. The number of orbitals in a subshell, that's not a quantum number. What is the orientation in space? That is your m sub L. Now the shape of the orbital, that's the one that is your L. Okay. So there is always a question about the orbit, what we call about what quantum number is all about. Okay. So the next one. So which of the following sets of quantum number refers to a 3D orbital? So I want you to look at it, and then I'm going to put the poll survey. So you choose A, B, C, D, or E. So these are the type of questions that you will have. You can make a mistake at this time, but the second time around, it's not sweeter to make the same mistake. Okay, so I'm posting now the survey. There are at least some students participating in the poll. In case you don't see it, okay. So let's see. So again, only 50% got it correctly. Now you may ask yourself, how are we going to get the correct answer, Professor? Okay, so if you're going to look at the question here, this is 3D. Okay, well, you cannot guess because you end up guessing also your grade at the end of the semester. So if you have a 3D, what does the 3D represent? It represents the N and the L value. Okay, so if you're going to look at this, so all you need to do is look for a number or a quantum number when N is equals to 3, and that's the only one that you have there. If you have this one, what is the orbital that you have here in 2 and 1? That is 2 what? 2p. right? What is S? S is equals to 0, P is equals to 1, D is equals to 2, F is equals to 3. So that is your L, or the L value that you have. Now, what is letter C here? What is the orbital of letter C? Or what is the subshells? The 3D, the three-dimensional, you don't use a small letter, you use it like this. Okay? So what is the subshell of this one here? This is for what? SPDF. Which one? That is a 4D. Okay? And this one is a 4. Anyone? That's a 4F. Now, what if you already have what we call 3 here, and then you have a 4 with 5 and a 6? What do you think is the next letter? Anyone wants to guess? What do you think follow after F? Literally. What letter follow F? G. And then this is H and this is I. So if you're going to look at this, this will be hypothetically as 5G. But there's no such thing as G. Okay? Because in the next chapter, when we meet in on Thursday, I'm going to discuss you what does this mean which relate to the periodic table. Okay? So let's try to go for the next question here. So a possible value for a magnetic quantum number M sub L for a 5D is what? So you're looking here for the possible value of M sub L when you have a 5D. So is it -5, 4, 2, -3, and 6? So launching the poll. So what is the possible value of your M sub L when you have a 5D? So the question there is, what is the L value? Because the M sub L depends on the L value. So to answer this question correctly, you need to know what's the L value. Because once you have the L value, you can get the M sub L values. Let's see. Some of you still don't know what is happening. So ending up, okay. So the average that we have is at least 53% got it correctly. Okay. Just to show you how you're going to answer questions like this. What is the value of L when you have D? Because that's 5D, right? So 5D have an N and an N sub and an L. So when L when you have there an L that is a D, that is equals to what? A 2. So when L is equals to 2, what's the possible value of your M sub L? -2, -1, 0, +1, +2. Okay, so that means you have 5 orbitals. 1, 2, 3, 4, 5. So The only one that has that number is this one. Analyze. Next one. So all of the following statements about the quantum number are true, except n may take up integral values from 1 to infinity. L may take integral values from 1 to n minus 1. M sub L has 2L plus 1 possible values. And M sub L may take integral values of positive 1 to negative, positive L to negative L, including 0. And MS may take only the values of positive 1/2 and negative 1/2. So try to internalize and then put your, place your answer in your mind. And here is the choices, the poll. So which of the statements are false? And we'll go on each statement one by one. I think based on this is a difficult question. Everyone is evenly distributed. Okay. So let's see. So before I share to you the results, n value may take integral values from 1 to infinity. So all of these are what? Positive values. So this is true. L may take integral values from 1 to n minus 1. Is that true? What is the value of L usually? It's from 0 to n minus 1. So this is the correct answer. But let's look at the other one. M sub L has 2L plus 1 possible values. So that means if you're given the M sub L's, you can determine how many values of M sub L using this one, this formula. So if your L is equals to 1, so you have an M sub L that has at least 3 values. So this is true. And then M sub L may take integral values from positive L to negative L, including 0. And then the MS can only take a value of 1/2 and negative 1/2. So look at this poll answer. So if I'm going to give this same question, this question that I given now, only 7 out of 40 got it correct. Okay. Let's try another one. How many values are there for the magnetic quantum number when the value of the angular momentum quantum number is 4? So what is the magnetic quantum number? Anyone? What is that? So you have N, L, M sub L, and M sub S. Okay, so that is M sub L. So you're asking here, how many values are there for the magnetic quantum number when the value of the angular momentum quantum number is 4. So what formula are you going to use here? So is it 1, 4, 10, 16, and 9? Okay. So choose your answer and survey said. Let's see. So the answer said, what is the right formula? Anyone? So you are asking here when L is equals to 4, how many M sub L values do you have? So it's the 2L plus 1. So this is equals to 2 times 4 plus 1. And result shows only 44% get it right. Okay. Next one. So an orbital has quantum number equals to n equals to 5, L is equals to 2, M sub L is equals to 2, and may be found in which subshell? Okay. So 5, n equals to 5, L equals to 2, and M sub L equals to 2. Let's see. Okay. That's n. So let's try to go. What is the value of n? And what's the value of L? That's all that you have from here. So this is what? They are all 5, right? So when you have S, what is the value of L? When you have S, what's the value of L? 0. Okay, when you have P, what's the value of L? 1. When you have D, what's the value of L? So that's 2. And when you have F, what's the value of L? That's 3. And when you have G, you have a value of L that is equals to 4. So this alone will tell you that that's the one that you have here, because the value of your M sub L would be what? -2, -1, 0, +1, +2. So let's look at the results. Da-da-da-dan, da-da-da-dan, da-da-da-dan. So only 53% got it correctly. Okay? So if you're going to have questions like this in your exam, make sure to get it correctly during that time. Next one. So what is the value of the spin quantum number for an electron in a 5F orbital? Okay? You have your answer already? 1, 2, there you go. So you're asking here for the spin quantum number. Okay? So what is the spin quantum number? So you have 4 quantum numbers. So you have N, L, M sub L, and M sub S. So what is the spin quantum number between the 4? So the spin quantum number is the M sub S. And the M sub S would only have what value? Either 1/2 or a -1/2. Now, some of you mistaken it for 3. So the correct answer there is letter E. Okay, so you have to know what the name of each quantum number: the principal, the azimuthal, the magnetic, and the spin quantum number. Next one. Which of the following subshells does not exist? So which one don't exist? Ready? So where's the other one? There's 49 of us, so that means 48. There's only 34 participating. This is the only time that we have this type of what we call session. If we're doing an in-person class, I don't think we have time for an occasion like this. So out of the 48 students, only 39 participated. Okay, so what is being asked here? Which of the following does not exist? So when you have n is equals to 1, And then you have L equals to, let's say, what? 0. When N is equals to 2, you have a 0 and a 1. So that means you only have an S for this. You have an S here and a P. When you have N is equals to 3, you have what? You have a 0, you have a 1, and you have a 2. So that means you have an S, a P, and a D. When you have a 4, that means you have a 0, a 1, a 2, and a 3, or an S, P, D, and F. And then if you have what we call a 5, then you have a 1, a 0, a 1, a 2, a 3, and a 4. So that means you have an S, P, D, F, G. And if you have a 6, so that means you have M sub L equals to 0, 1, 2, 3, 4, 5, 6. So that means you have an M sub L, or a sum of these L values, S, P, D, F, G, and H. So 2S, you have here a 2 and an S, so that exists. 3P, you have a 3 here and a P that exists. 4D, you have here a 4 and a D that exists. Now 3F, in the 3, you only have S, P, and D. So you don't have this one. 6G, you have a 6 here and a G there, so that exists. So what does the poll says? Only 15 out of 40 students got it correctly. Okay? Well, I expect it to be like that because we just discussed this thing today. But as we go on, you should at least know better. This one. Which of the following sets of quantum number is not permissible? So I want you to select before I put the poll survey. And maybe the way we can answer it is what subshells each of the choices gives us. Okay, so hopefully you're going to get this correct. So when you say it's not permissible, the subshell don't exist. Or it cannot be what we call possible. So before we show the survey or the poll answer, so there's only 30 students who showed up or at least participated in this question. So survey ends in 4, 3, 2, 1. So let's look. 100. So what's the subshell that refers to this? What subshell is this? So you have an N equals to 1 and L is equals to 0. So this is what subshell? A 1S. 400 1/2. What subshell is this? That's a 4S subshell. 2 equals to 2. Is this a subshell? Can you have a subshell that has n equals to 2 and and l equals to 2? The answer is no. So this is the correct answer. Letter D, what subshell do we have here? Anyone? What subshell is 3 is equal, n equals to 3, l is equals to 1. That's a 3p subshell. And then letter E, 3n equals to 2, that's a 3d subshell. So if we're going to look at the poll answer, only 39% got it correct, but at least that's the, we could say, plurality of all the students. Okay? How many orbitals are there in the n equals to 6 shell? So let's see. Let's see if you know the formula that you're going to use. Okay, falling in 5, 4, 3, 2, 1. So answer ends in 5, 4, 3, 2, 1. What formula are we going to use here? Anyone? Before I share the result. How do we know the number of orbitals when n is given? So that's just the n squared. So 6 squared is equals to 36, of which 40% of the class got it right. Okay? So that's the last one that we have. So if you're going to look at this question that I asked you, you may wonder where I got it. I got this from here. And this is what? Your full questions. So if I'm going to ask you to answer, let's say this one here, 39. What is your answer there? Which of the following is a representation of a 1s orbital? So A, B, C, D, or E? I can still pull what we call the poll question, I mean the poll survey, so at least I could still see if you really understand. So you have the SPDF. What did I say? Spherical, peanut, double peanut, and flour. So if you have a question like this, obviously, most of you should get the correct answer. And that is, I'm going to end the survey now. Letter A. Well, at least 77% of you got it right. And the last question that I have here is this one. The same, I think, choices, but the one that's being asked is which is a 3D XY. So which do you think is the 3D XY? So this is what? A d orbital. So if you're going to ask, if you're given, let's say, a diagram of these orbitals, you should be able to answer it correctly. So which do you think is the right one there? Okay, so if we're going to look at this, so this is an S, a D for double peanut, and this is a peanut, and this is a peanut. So the choices that you have there would be this one. Although a D, this letter D is also, we could say, a d orbital, but the one that is obviously here is the so-called the C. Okay, so at least 58% got it correctly. Okay, now question: how many are done with chapter 4, owl? Or maybe I can put it in a poll question. So I'm just typing. I just want everyone to participate. So where's that? Poll question. Stop sharing. So the next thing that I'm going to ask, oops, it doesn't want to give me in. It doesn't want to let me in. So when do you want it to be extended? Until midnight, until tomorrow, or until Tuesday? Or until Tuesday, until Thursday, not Tuesday, sorry. Until Thursday, today is Tuesday. No, I cannot do it next week. Okay. And I have to do it now just to show you, because if I'm not going to do it now, I might forget it. And then by the end, what will happen? Everyone will just say, Professor, you promised. What do you mean next Thursday? No. Okay. So this is what we have. Because we're done now with chapter 7. So if we're going to look at this is what? Chapter 4. So today is October 26. So we're going to make it what? October 28, 11 p.m. Is that okay? Okay. 11:59, as if the 59 minutes will do anything. Does it work there? And then when will I put this one? When do you want this to end? Because usually I give a week. So can I just make it November 4? At 11:59 also? My God, you want to move it all on the later part and everything will just be what we call filled up by the end. Maybe the 8th. No, because when is the exam? Do you know when the second exam is? We might be done in one meeting for chapter 8. Okay, so the exam is on the 12th, so everything should be done before the 12th because it's useless to do it after the exam. So you're defeating the purpose why we do that thing. Okay, now the quizzes is already available and you can only have one try, and if I'm not mistaken, the deadline that I set for both of them is next week. Okay, the quizzes in the classes. So any more? Only one show up in my office or next week, yesterday. So I don't know, especially to those who are not doing well, I think you have to what we call double your effort. Attend the session by Cheyenne. I think nobody's still showing up in his session. So if your score is maybe less than 1/2 of 25, then you should at least have to double your effort. You should also take advantage of the tutoring session that they have. Okay, it's free. So just take advantage of it. Okay, so any more questions before we call it a day? And hopefully we see each other in person next meeting. Any more?